Hello everyone. We will discuss today the chapter Work and Energy. In this chapter, first of all, we will discuss about work. Later on, we will talk about the energy. What you understand by this term work? And when we say someone has done some work in daily life, we use this term for any activity like for attending class, drawing diagrams, collecting question papers, or playing games, etc. We count it as work. But the scientific definition of work is totally different. By this definition, work done is said only when some force should be applied, and with respect to this force, some displacement is also observed. Then only we will say the work is done. So, in this do condition, it must be satisfied for doing some work. Let's take an example. Let's suppose this is an object and you applied a force F. Because of this force, this object displaced to a distance s, then we can say you have done some work. If any of two cases condition isn't satisfied, then we will say work isn't done. Let's take an example for those cases. First, in first case, we apply force F, but our displacement is 0. You have a ball and you pushing it from here with a force F, but this ball doesn't move, or say S is equal to 0, then it is said you have done 0 work. Now take an example where force is 0 but displacement is observed. Let's take a ball moving with velocity v. It's remain with constant velocity a distance s from initial position. Then here force is 0, so velocity doesn't change and displacement is some value d. Then also we will say work done is 0 here. Now move to our new concept about count of work, or say what amount of work a person have done will account this work. By definition, if a constant force F is applied here and the subject move a distance s, then work done by this force is equal to F cross s, or say force into displacement. By this formula, we can get the unit of work as Newton meter. It has also a unit called joule, or say capital J. So by definition, the 1 joule of work is defined as by a constant 1 Newton force. The displacement observed is 1 meter. Now look on some question based on this concept. Take example number 11.2. In this example, we have given mass of luggage is equal to 15 kg and displacement is given as 1.5 meter above the ground. So we have to find work done. So first of all, we will find force to bring the object of weight 15 kg. So it must be a gravitational force mg. So here force is mass into acceleration of gravity. So mass is 15 kg and acceleration of gravity is 10 meter per second square. So here force is 150 Newton. Now the displacement is given as s is equal to 1.5 meter. So work done by that guy is 150 Newton into 1.5 meter, which is equals to 225 Newton meter or 225 joules. Now take question 4 from exercise. In this question, force exerted is given as 140 Newton and the displacement is given as 15 meter. So here work done by is given as 140 Newton into 15 meter, which is equals to 2100 joule. So that's all in this class. We will discuss in next class negative of work done and the concept of kinetic energy. Thank you.